Today I am going to teach you polynomials chapter 2 of 10th class. In this introduction, geometric meaning of zero of the polynomial, relationship between zeros and the coefficients of the polynomial. These three things are there in this chapter. So introduction, first let us understand what is a polynomial. What is a polynomial? It is an algebraic expression. Algebraic expression. But when with one condition, the powers are exponents of the variables should be always a positive integer. A positive integer. So in general form, let me write a general form, because I am not teaching in detail. Px, polynomial of the variable x. Actually px is a function that you are going to learn later. So usually we denote polynomials using this notation, either p or g of x or h of y. That means h y is a polynomial in the variable y. Okay, k, z, whatever. So usually in our textbook he used px. Okay, px is a polynomial. So in this we have it is a polynomial. There are let me write an example: x to the power of 4, 3x square minus 7. So this is a polynomial, and the powers should be always the positive numbers. 4, 2. There is no variable in the. It is a constant term. I am not going in deep. Let me explain. This is a degree 4 polynomial, because highest power of the polynomial is 4, so it is a degree 4 polynomial. Then 0. Let me recall what is the 0 of the polynomial. 0 of the polynomial, it is the value of the variable. It is the value of the variable where this entire, at which the entire polynomial becomes 0. Okay, for example, at x is equal to 2, this entire polynomial is 0. Then what happened? You have to replace, that means p2 in the place of x, we should write 2. So p2 is equal to 0. If p2 is equal to 0, that means at x is equal to 2, this entire value is 0. Then 2 is called 0 of this 0 of px. So 0 means it is the value of the variable at which the polynomial becomes 0. Okay, that is the 0 of the polynomial. Now this is a 4th degree polynomial, and if you want a 2nd degree polynomial, you can write 3x square minus 3x plus 4. Okay, so now let us, in this chapter it is mainly dealt with degree 2 polynomials, degree 3 polynomials, and also degree 4 polynomials, right? So let me go to the standard form of the polynomial, degree 2 polynomial. Okay, degree 2. I am not degree n polynomial. I am not giving you like a question. You can have a degree n polynomial. I am writing degree 2 polynomial. I am writing general form: ax square plus bx plus c. So this is the general form of a polynomial. General form. Okay, our standard form of the polynomial. It is a quadratic polynomial. It is a quadratic polynomial because highest power is 2. It is a 2nd degree polynomial also. Now let us understand one by one. Variable is what is the variable in this? Variable is x. Degree, of course, I need not tell you, degree is 2. Then there are other things, a, b, c are real numbers. They can be real numbers. And there is one more condition. If a should not be equal to 0. If a is equal to 0, then what happens? 0 into x square will become 0. X square term will disappear. Then it will not be a quadratic polynomial. That is why a is not equal to 0 if you wish this px should be a quadratic polynomial. Okay. So, and a, b, c other than a0, any real number you can have root number, anything. Okay. So, this is the understanding of the polynomial a. Then what happened to the b? B can be 0 and c also can be 0. If both are zeros, what happened? Px is equal to only ax square will be there. If b is equal to 0, this term, second x term will become 0. C is equal to 0, then constant term will become 0. So then only px is equal to ax square will be remaining. Yes, this is a quadratic polynomial. So condition for quadratic polynomial is degree should be 2. So only one condition for a quadratic polynomial, a should not be equal to 0. Okay. So this is the understanding of quadratic polynomial. Now, how many zeros will be there? Number of zeros. Number of zeros usually depend on the degree. So because it's degree 2, there will be 2 zeros for this polynomial. So there will be 2 zeros. Usually alpha is a Greek letter, alpha is 1 0 and beta is beta is one more 0. Usually alpha, beta are the Greek letters. We denote roots in general. If you want to denote the roots in general, we can, because x, y, z, a, b, c, d we are using in the polynomials. A to z we are using. So we need some other letter to represent the roots. So that's why we brought alpha and beta, some Greek letters we brought. So now these are the zeros. Some people will get confused. They write alpha, beta, that means zeros and the roots are same. No. 0 we use it for polynomials. Root we use it for quadratic equation. Quadratic polynomial, quadratic equation. Roots usually we use that word for equation. 0 we use for polynomials. Okay. There are 2 zeros. So now our target is how to find the zeros of the polynomial. Zeros of the quadratic polynomial. Okay. Let us take an example and understand. So let me take px is equal to x square plus 5x plus 6. This is a quadratic polynomial. How to find zeros for this? Okay, so you have to express this expression, that means polynomial, as a product of linear factors or product of 2 factors. So this product should be a linear factor. So linear factor means the degree is 1, linear polynomial. Okay, product of 2 linear polynomials we can write. So this expression should be written as a product of 2 linear polynomials. Why linear polynomial? Let me explain. Ax plus b is equal to ax plus b is a linear polynomial. So for linear polynomial, 0 will be very easy. 0 is equal to minus b upon a. So my x is equal to minus b upon a. This is the 0 of the polynomial, linear polynomial. So once you get the linear polynomial as a factor, then automatically you will be getting zeros. So how you got minus b by a? Very simple. Ax plus b is equal to 0, and find the value of x. Ax is equal to minus b and x is equal to minus b by a. This is the value of x where this entire linear polynomial is 0. So minus b by a is a 0 of the linear polynomial, linear general polynomial. So now x square plus 5x plus 6 you have to factorize. There are so many methods, you will learn by yourself. I will write directly the factors. So x plus 2 is one factor, x plus 3 is one more factor. You will learn how to find the factors. So this is factorization method to find the zeros of a quadratic polynomial. Now we have got two factors, x plus 2 is one factor and x plus 3 is one more factor. These two are linear polynomial. The 0 of this is minus 2 and the 0 of second factor is minus 3. So then what happened? Minus 2, minus 3 are zeros of px. That means the given polynomial. So this is one model number 1, how to find the zeros. Find the zeros of the quadratic polynomial. I will just give you a few questions for your practice. Okay, I will not denote with the px is equal to, let me denote completely. So x square minus 17x minus 60. This is first question. And gx is equal to, I want you to find out the zeros of the polynomial of these things, okay, of these two. I will give you only two examples. 2x square and minus 17x plus 30. So I gave you two questions. I want you to find out the zeros of this polynomial. So now let us understand the meaning, geometric meaning of zero. Of any polynomial. I will write of a polynomial. It is not only quadratic polynomial, of any polynomial. So px is a polynomial of any degree. Px is a polynomial of any degree. So let us understand what is the graph, geometric. How do you keep this, how do you represent this in the graph? Very simple. You in the graph, in a coordinate, if you want to draw the graph, you need the two coordinates, x coordinate and y coordinate. Suppose px is equal to, for example, x plus 2. So let us say this is y and this is x. So give x values and you will find y values. xy is the coordinate. Put the coordinates in the graph sheet and join them. Join using the freehand. So you will be getting a graph. So that means you need to use a coordinate plane. Say for example, I am writing a coordinate plane. Coordinate plane consists of two coordinate axes. One is x-axis, the other one vertical line is known as y-axis. X-axis and y-axis. Okay. So now if you represent a polynomial, you will get some graph. Okay, let us take a line only, because linear polynomial you will be getting a line. If you draw, you will be getting a graph of a polynomial. Let us say this is the graph of a linear polynomial. So now it is intersecting at this point. Okay, so that means let us say for example this is 2. So then what happened? X is equal to 2. X is equal to 2 is the 0 of this polynomial. Okay, let us take this only. Px is equal to minus 2. I will write minus 2. Now you put x is equal to 2. Then what happened? 2 is equal to 2 minus 2 is equal to 0. So that means P2 is equal to 0. So this is this point is 0 of the polynomial. That means if the wherever the graph meets the x-axis, okay, and that point x value is the 0 of the polynomial. For example, p y is equal to y minus 2 or something y minus 3. So then what is the 0 of this? So this has to intersect y axis. So this will be the 0. For example, if this is 3, then what happened? 3 is the 0. 3 minus 3 is 0. So 3 y is equal to 3 is the 0 of this. Okay. Now usually we don't go for this. We use only px. Okay. We use only px. So then we go for x related graph only. So straight line definitely will meet the x-axis at only one point. So don't think that all graphs are straight lines. Some graphs are curves also. Okay, some graphs will be coming like this. So then what happened? This polynomial graph is meeting x-axis at two different points. Let us say this is 3 and this is minus 2. So 3 and minus 2 are the zeros of this polynomial. Sometimes this will not be meeting. Okay, this graph is not meeting. It goes like this. At this what happened? It is not meeting the x-axis, therefore it has no zeros. So there are polynomials no zeros also. Okay, sometimes what happened, the graph will meet at only one point. Okay, so I am writing for all the things u-shaped curve only. So sometimes the graph meet at only one point. Yeah, this is also a possibility. So then what happened? This value is 0 of the polynomial. So this is the geometrical meaning of the 0 of a polynomial. So that means if you want to find zeros geometrically, you have to draw the graph of the polynomial, and the graph definitely meets. Sometimes it meets and sometimes it won't meet. So wherever the graph meets or intersects the x-axis, and those intersecting points will be the zeros of the polynomial. This is the geometrical meaning of the polynomial. In exercise 2.1, he has given 6 graph sheets, 6 graphs, and you have to identify the zeros of the polynomial. So 6 graphs of px are given. You have to identify number of zeros. How many zeros are there? So that is exercise given in the textbook that you can do it by. So now understanding of geometrical meaning is over. Now let us understand the relation between zeros and the coefficients of the polynomial. So for this, let us take px, general quadratic polynomial, ax square plus bx plus c, where a is not equal to 0. Okay. So now we have to find the relation between these zeros. Zeros. Let the zeros be alpha is 1 0 and beta is 1 0. So the relation, the first relation is sum of zeros is equal to minus y coefficient by x coefficient. So what is y coefficient here? B. So minus b by x coefficient is 0, a. So Then what is the sum alpha and beta? So alpha plus beta is equal to minus b by a. So this is the relation between zeros and the coefficients. Okay, so alpha plus beta is equal to minus b by a. You can remember like that, or you can remember sum of zeros is equal to, because you are not bringing alpha beta in this formula, so you are not bringing in this sum of zeros is equal to minus coefficient of y by coefficient of x. So there is another relation, product, sum and product. So product of zeros is equal to product of zeros c by a. So that means c by a means c is constant by coefficient of x. So this is if you bring the alpha beta into this, alpha into beta is equal to c by a. This is another relation. There are two relations. One relation is alpha plus beta. Okay, another relation is alpha into beta, sum of the zeros and product of the zeros. Don't use the word roots. Okay, sum of the roots is alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. This is the zeros of the relations between zeros and the coefficients of quadratic polynomial. Cubic polynomial, we are going to have it later. I would like to give you one extra information, how we have got these relations. That means how I got alpha plus beta is equal to minus b by a, and how I got alpha into beta is equal to c by a. I will just write in simple. So ax square plus bx plus c. This is our general form of the polynomial. So here let us write x minus, because if alpha is a 0, the related linear polynomial is x minus alpha. If beta is a 0, the related is x minus beta. So k is a constant, common number. Okay, so this is because I gave you how to find the zeros. You have to express the quadratic polynomial in the product of two factors. I have written k, sometimes k is equal to 1 also, sometimes k may be some other number. So if you just open it, what happened? Kx square, okay, minus alpha plus beta into x plus alpha beta. Here also k will be there, in everything k will be there. Okay, kx square, k alpha beta and k. Okay, so then what happened? A is equal to k. Compare, because this x square term is to x square term and x square term. Left hand side x square term is ax square, and right side x square term is kx square. Kx square will get cancelled, a is equal to k. That means equating the like terms on both sides of the equation, because this is an equation. So if you compare, then what happens? Bx is equal to minus k into alpha plus beta, and x is equal so then x cancel, and b is equal to minus k into alpha plus beta. Okay, so then alpha plus beta is equal to minus b upon k, at k value is a, so which is equal to b, minus b by a. And the third term is remaining, and c is equal to k alpha beta. So then alpha beta is equal to c by k. So k is already value a, so alpha plus alpha beta is equal to c by a. This is a simple understanding of how we got these relations. Okay, let us go to the next point. So here some exercise is there. Some exercise is given. Say for example, find the zeros. Example number 1. Find the zeros of x square plus 7x plus 10. Find the zeros. How to find the zeros? Using the factorization method, and compare the relations. Verify the relations. What are the relations? Sum is equal to minus b upon a. This is you have to verify whether these relations are correct or not. We have to verify with an example. Whenever a formula is there, you should verify the formula. So now formula is given, sum is equal to minus b by a and product is equal to c by a. So as per this, what happened? Sum is equal to minus b is 7, so minus 7 upon 1 is equal to minus 7. Sum is equal to minus 7. And product is how much? 10 upon 1, which is equal to 10. Now let us find out the zeros. Factors are, what are the factors? X plus 2 into x plus 5. I am aware of the factorization. I can do it immediately. For you it will take little time. So what is the 0? 1 0 is minus 2 and 1 0 is minus 5. So 2 zeros. Minus 2 and minus 5 are 2 zeros. So now sum, you have to add minus 2 and minus 7. Minus 5, I'm sorry. So minus 7 minus, it is verified, correct? Let us multiply here also. Minus 2 into minus 5 minus plus, it is equal to 10. So this is relation is verified. This is one of the question, important question. You may be getting it in 2.2 exercise. This model is available. First question, find the zeros of the polynomial. 2.2 exercise, find zeros of the quadratic polynomial and verify the relationships. Okay, this is one. In 2.2 exercise, there is a second question, one more question, exercise 2.2, and second question. Let us do second bit. So sum of zeros are given. Sum of zeros is equal to root 2 and product is equal to 1 upon 3. So if alpha beta are the, you have to find out the zeros. Find the quadratic polynomial. So find quadratic polynomial. Quadratic polynomial means ax square plus bx plus c. You have to find out. That means a, b, c values you have to find out. So that means minus b by a is equal to root 2. Sum is equal to minus b by a. That is the relation between the zeros and the coefficients. And product is equal to c by a. C by a is equal to 1 3. So there are two equations, equation 1 and equation 2. So in equation 1, equation 2, a in both the equations denominator is a. So but in the second equation a is equal to 3. So now let us make minus b by a is equal to 3 root 2 by 3. That means I made denominator same. I made denominator same in both the equations. So then a is equal to 3 and minus b is equal to 3 root 2 and b is equal to minus 3 root 2 and c is equal to 1. So then what will be the quadratic polynomial? Therefore, the quadratic polynomial is equal to formula ax square, general form bx plus c. So if you insert the values, a is equal to 3, 3x square minus 3 root 2x plus 1. So this is one more. 6 bits are given. 1 bit I have done, and remaining remaining 5 bits you can do for your practice. So with this, polynomial chapter is over. If you are having any doubts, you can put it in the comment box. Some extra questions, examination questions, I am going to discuss separately. I am going to teach only the concepts in the videos. The extra practices, worksheets, and all these things will be given in my app. I have an app, Dear Teacher. You can download it directly from Google Play Store. And also I have a website, ravishankar.online. So you can log into the website and get the information. Those who want to have tuition with me, those who want to learn problems with me, you can join my online tuitions, or if you are nearby living place, you can join with my offline tuitions also. Have a nice day. Happy learning. Bye bye.